A deep dive into sklearn Gaussian process regression. The sklearn Gaussian process module provides tools for implementing Gaussian process GP regression, a powerful non-parametric Bayesian technique for modeling complex relationships between input and output variables. 1. The essence of Gaussian processes. Non-parametric. Unlike traditional models with fixed parameters, GP models capture the underlying function through a distribution over functions. This allows for flexibility and avoids assumptions about the underlying function's shape. Bayesian GP models incorporate prior knowledge about the function and update this prior based on observed data. This provides uncertainty estimates for predictions, which is crucial for reliable decision making. Kernel-based. The core of GP regression is the kernel function. It defines the similarity between input points and determines the smoothness and structure of a learned function. 2. Key components of sklearn Gaussian process. Gaussian process regressor. This class implements GP regression and is the primary tool for building GP models in sklearn. Gaussian process classifier. This class extends GP regression for classification tasks, enabling probabilistic predictions for categorical outputs. Kernels. sklearn provides a collection of built-in kernels, including RBF radial basis function, a classic kernel for capturing smooth nonlinear relationships. Matern. A family of kernels with varying degrees of smoothness, offering control over the function's complexity. Rational quadratic, suitable for modeling functions with both short and long-range correlations. Dot product for linear functions or situations where inputs are already in a suitable feature space. Constant. Kernel represents a constant offset in the function. 3. Building a Gaussian process model in sklearn. Initialization. Instantiate a Gaussian process regressor object, defining the kernel function and hyperparameters. Fitting. Train the model using the fit method, providing the input X and target Y data. This process optimizes the kernel's hyperparameters to best fit the observed data. Prediction. Use the predict method to obtain predictions for new input data. Uncertainty quantification. The predict method also returns the predictive variance at each input point. This represents the uncertainty associated with the prediction, providing valuable insights into the model's confidence. 4. Hyperparameter optimization. Kernel hyperparameters, e.g., length, scale, variance, control the smoothness and flexibility of the learned function. sklearn offers several approaches for hyperparameter optimization. N-restarts optimizer randomly restarts the optimization process multiple times to avoid getting stuck in local optima. Optimizer specifies the optimization method, e.g., LBFGSB, used for fitting the model. Random state sets a seed for random initialization of the optimizer, ensuring reproducibility. 5. Advantages and disadvantages of Gaussian process regression. Advantages. Non-parametric. Adapts to complex relationships without making strong assumptions. Provides uncertainty estimates. Facilitates robust decision making. Relatively simple to implement thanks to sklearn's Gaussian process regressor class. Disadvantages. Computational cost can be computationally expensive for large datasets, especially during hyperparameter optimization. Sensitivity to hyperparameters requires careful selection and optimization of the kernel function and its hyperparameters. May overfit in high-dimensional spaces. Can be prone to overfitting with a large number of input features. 6. Applications of Gaussian process regression. Time series forecasting, predicting future values based on past observations. Spatial interpolation, estimating values at unobserved locations based on data from nearby points. Robotics, learning robot control policies and predicting robot behavior. Machine learning is a powerful technique for function approximation and Bayesian optimization. 7. Advanced techniques. Multiple output Gaussian processes extends GP to handle multiple output variables, allowing for joint modeling of correlated outputs. Sparse Gaussian processes approximations that reduce the computational cost for large datasets by using a subset of the training data. Bayesian optimization utilizes GP to efficiently find optimal solutions in complex search spaces. 8. Summary. sklearn's Gaussian process module provides a powerful and versatile framework for implementing GP regression. By understanding the key concepts, components, and best practices, you can effectively leverage this technique for various machine learning tasks. Remember to carefully consider the choice of kernel function and hyperparameters, as they significantly influence the model's performance.